Hello and welcome back to Getting Started with BGFX. So in this episode we are going to load an image from the hard drive or solid state drive, whichever one you got, and we're going to render it to the screen. So let's dive right into it. So this is the texture that we're going to be loading from the disk and displaying on the screen. I got this from the Vulkan tutorial website and I've been using it in all my projects. So first we need to save this to our to the project folder. So right click, save as. I'll include this into the GitHub repository so you won't need to do this. Yeah, let's go here, Here's me, source, repos, Getting Started with BGFX. Go into the project folder and save it. Righto, let's dive into our project. So we're going to make an image class. So we'll go into our Solution Explorer. We'll make a new header file. We'll make this image.h. And we'll set about creating this. First we need to include the BGFX header file. We'll create our image class. The constructor will take in the const char of the file name. We'll provide a destructor so that will destroy the image when we're finished with it. Now we need to get the texture handle, BGFX texture handle, get texture handle, we'll return m_texture handle, then we'll create that, we'll go BGFX texture handle, m_texture handle. Alright, that's done. Now let's implement this. So we'll create a new source file. We'll call this image.cpp. First up, we need to include our image header file, image.h. We'll include print so we can print an error message. Now, first thing is we need to define stb_image_implementation. This is what you need to do when you're including stb image so that you don't get any linker errors. So now we can include stb_image. Now let's create our constructor. We'll get our width and height. So first we'll need to create those variables. Now we need to call the stb load function, and that returns an array of data. So it is uint8_t data, it's a pointer, equals stbi_load. Provide the file name, then we need to provide the address of the width and height so that it'll have those afterwards. Now I'm not sure what this is, we just provide null. Now this is where we give it stbi_rgb_alpha. And this is null pointer, always get that wrong. So what this will do is that regardless of whatever image format we load, it will always have RGB and alpha, which is what we want because we're always going to provide an alpha. Alright, now that we've done that, we'll create the image itself. Texture handle equals BGFX create texture 2D. Now we need to convert the height and the width to 16_t, so it's unsigned. So getting it out of STB, it has to be signed, but in this it's unsigned, so we have to convert it. That's meant to be a comma, not a semicolon. Okay, here's MIPS. I don't really understand what MIPS is, but I just always say false. It's always going to be one layer. Now we give it the texture format. It's going to be BGFX, texture, format, enum. This is RGB A8. So what that means is we have red, green, blue, and alpha, which we do get from here. And each of these is 8 bits wide. Alright, so what we'll do is we'll provide it with samplers. So first one is BGFX underscore sampler underscore point, and then we'll all that with BGFX underscore sampler underscore UVW underscore clamp. So what this one is defines the type of algorithm that we're using if we expand it or contract it. So point means that it's just going to look very pixelated when we expand it. And UVW clamp, so if we are sampling if we're going beyond the edges of the texture, this will tell the renderer what to do if it goes beyond the edges. So it's just going to stick to the edge of the image, so that if we go beyond the right hand side, for example, it will just stick to whatever pixels are on the right hand side. Or if we go to the left hand side, if the texture coordinates is below 0, for example, it will just stick to the right hand side. Or if the image is just too big, if we're trying to render a 10 pixel image in 1000 pixels, what is this going to do? Okay, so clamp, and actually if we just go to the definitions, you can see others. So mirror means that it just goes back to it'll wrap around, it'll go back to the beginning. And border, I'm not sure what border does, but I just use clamp. Alright, finally now we give it the data. So we go BGFX copy, open bracket, data width times height times 4. Okay, so we need to do this calculation because width and height will give us the number of pixels in our image, and there are 4 bytes per pixel. Alright, that is the image created. So now we can delete the data because we've copied it into BGFX, we don't need it anymore. And now we can just check if it's valid. It is valid, and just pass it in the texture handle. And we'll just print. Unable to create image. Alright, now we'll do the destructor. So we go image, tilde image. And then we can just go BGFX, destroy, texture handle. Done. Okay, so let's go back into our main file. So we'll do this after first we need to include the header. So we'll go up to here, we'll include image.h. Now we'll go down here, we'll create our image. And it's called texture.jpg. and that will create an image. Now before we can use this, we need to modify our fragment shader. So if we go back to our fragment shader, first thing we need to do is we need to include what's called a uniform. So we can pass in additional variables into our shaders. They're called uniforms because they don't change. So this texture is not going to change for the entire time this shader is executed. Our image is going to stay the same. So BGFX has a special macro called sampler 2D, open bracket. Give it a variable texture color and 0. So what 0 means is that's the slot number. You can have up to 16 slots, and you just say if you want to add another sampler, you just do this, call it texture color 2 and slot 1. And that will become a bit more clearer once we create the uniform inside of our code. Okay, so next what we need to do is we need to multiply texture 2D, open bracket, texture color, colon, and v underscore text chord 0. So what that does is that this texture 2D is a special function that takes in our texture, and that's meant to be not 1, takes in a texture, takes in the texture coordinates that the GPU has calculated from this point, because it what's called interpolates between vertices. So the vertex on the very left might have an x coordinate of 0, over here might have a x coordinate of 1. As it goes along between those two vertices, it calculates what the texture coordinate would be for that particular pixel. So roughly about the middle here, it'll be 0.5. A quarter of the way along, it'll be 0.25. If it gets closer to the vertex on the right hand side, it gets closer to 1. So then it takes that, takes the texture coordinates and gives us the color from that texture, and we can multiply it with the color that's coming in from the vertices. Alright, so now that we've done that, we need to build our shaders again. So we'll just go into our file and we'll just run build shaders. That'll be done. Just to prove that there are no errors. Yep, no errors. Alright, what we need to do now is we need to create what's called a uniform. So that is essentially a pointer to this variable inside the shader. So we need to tell BGFX that this exists inside the shader, and so that we can set the texture. So we go BGFX : uniform handle, call this uniform, equals BGFX create uniform, open bracket, double quotes. Now we give it a name, call it texture color, and we give it the type of uniform. Uniform type. This is a sampler, and as you can see, there are a few things you can pass in. You can pass in a 3x3 matrix, a 4x4 matrix, or a vector 4. But we're going to do a sampler because we're passing in a texture. Now this name here, you only have to match it with this if you're in OpenGL. I've tried it, and if you're using something other than OpenGL, it doesn't matter. Okay, so just for OpenGL. Alright, so now what we can do is we need to use our texture. So we'll go up to here under the clear view, so we'll go BGFX set texture, open bracket, and we give it the slot number, which is 0. We'll give it our uniform, and we need to give it our texture handle. Okay, now before we shut down BGFX, we need to of course delete the image, and we need to destroy the uniform. Now before we run it, let's go up to here, go up to our vertices. We'll change the x coordinates to 0.28, so that will make our square actually look square. And the other thing we'll do is we'll change all of our colors to white. Reason is, it will, as you saw in the last video, our square was all sorts of different colors, so it will multiply that color of the shape with the color coming from the texture, and it'll be a mix of those colors. We want the color from our texture. Alright, done all that, let's run it. And there is our image loaded from disk. It's nice and square, and it's showing up in our window. Alright, last thing we're going to do is, what if we just want to draw a simple square, simple colored square, no image. Now that's the fragment shader always uses a texture, how can we draw a square? Well, it's simple. What we do is we create a 1 by 1 pixel wide white texture and use that when we want to draw a colored square. We only need 1 pixel because if the texture coordinates go beyond the edges of the texture, then it just gets clamped to the edges. So no matter how big a square we want, we always get that 1 pixel. So to implement this, we need to modify our image class. So we go to our image class, and we're going to add a second constructor that's going to pass in a void pointer of data. We need to give it the width and the height. Alright, let's implement that. So we can actually just copy all this. But we don't delete it because the data is coming from outside of our image. We don't want that. Okay, done that. Very simple. So what we're going to do now is we'll go back into our main function, and we will go down to underneath our image, and we'll create a white image. So first we'll give it the data. We only need 1 pixel, so 1 uint32_t white equals Yep, that's correct. And then we'll create our white image. We'll call it white image. Pass in the pointer to our white data, and width and height is just 1. Now we need to delete it. And just to prove that it does work, we will first set these vertices to just red. So we'll set them all to red. And instead of using our image that's loaded from disk, we'll just use the white image. And let's run it. And there's our red square. So let's change the color a bit. Let's change it to that. Always like to change the color and just see where we get to. There we go, we've got ourselves a nice purple color. So that's it for this video. We got ourselves a image loaded from disk, and we created a white image that we can swap in and out. So that's the makings of a basic renderer, which we're going to do in the next video. So now you can load whatever image you want, or you can just render a plain old colored square. I'll upload everything to GitHub, and I will see you in the next video.